If you step into the enterprise software market right now, you're immediately flooded with a confusing overlap of terminology. Vendors promise that everything is powered by AI, machine learning, or autonomous agents. To make sense of this, we have to map these systems on two axes: implementation complexity and enterprise value. When the current market terminology spills out onto a chart like this, it looks like a clustered mess. That mess causes a specific problem. Business leaders often treat AI as a single plug-and-play product. In reality, it is a highly specialized stack of disciplines, each engineered for very different tasks. Misunderstanding that stack leads to expensive mistakes. You risk over-engineering your systems, burning through capital and delaying product launches by forcing a hyped, complex architecture onto a problem that required a simple equation. You also risk under-engineering. Relying on a basic generative model for a task that demands strict factual accuracy will quickly erode user trust and damage your brand. This complete view of the AI hierarchy shows the sheer scale of the landscape. Choosing the right tool requires understanding how all these layers relate to one another. There is a central trade-off driving every decision in this space. As you move up the hierarchy, system capabilities shift from basic analysis to autonomous action. In exchange, setup costs soar, and the need for strict guardrails drastically increases. We are going to translate this complex hierarchy into a functional decision map. By the end, you will be able to match your specific business problems to their lowest cost, highest reliability AI tier. We start at the foundation of the stack. These lower tiers are systems built entirely to recognize patterns in existing data, rather than create anything new. This comparison matrix contrasts traditional machine learning with deep learning, splitting pattern recognition into two specific use cases. Basic machine learning is your ideal architecture for structured data. If you need to forecast numbers in a sales spreadsheet or cluster user demographics based on clear metrics, this is your tool. The output of basic ML is highly reliable. It delivers mathematically proven predictions that operate quickly and cost very little to run at scale. However, ML breaks down when the inputs become messy. When you move from clean spreadsheets to complex media, you cross the threshold where an upgrade to deep learning becomes structurally necessary. Looking at the deep learning tier of our diagram, you can see how it processes unstructured data by passing inputs through multiple hidden layers of a neural network. This architecture allows a system to identify objects in images or transcribe messy audio files. But the trade-off is steep. It requires massive sets of cleanly labeled training data and highly expensive GPU compute power to function. Both machine learning and deep learning deliver excellent analytics, but if your business needs to dynamically generate new text, write code, or create media on the fly, these analytical tools are useless. You have to move up the hierarchy. That brings us to the jump from analyzing data to dynamically creating it, using generative AI and large language models. Standalone Gen AI offers an immediate appeal. Users can prompt a system to instantly and cheaply draft text or code, relying on the model's broad internet training. But standalone LLMs carry a critical flaw for enterprise integration. They frequently hallucinate facts to fill knowledge gaps, and they are completely blind to your private, internal company data. To ground generative AI in reality, enterprise architects rely on a specific solution: Retrieval Augmented Generation, or RAG.
This section maps the internal mechanics of a RAG pipeline, entirely different from a simple prompt. Implementing this requires a structural tax. Before the system can work, businesses must embed stored knowledge and convert private documents into a vector database. During the retrieval step, the system intercepts the user's prompt, searches that vector database for relevant internal data, and then forces the LLM to generate its answer using only that retrieved context. By explicitly citing internal data, RAG virtually eliminates hallucinations. But it adds significant infrastructure costs, introduces latency into the system, and forces your engineering team to actively maintain those vector databases. RAG turns Gen AI from a brainstorming toy into a highly factual business tool. Yet, even with RAG, the system sits idle until a human user initiates a prompt. The apex of the hierarchy moves beyond answering questions. We are now looking at systems designed to autonomously execute multi-step goals. An AI agent separates itself from a standard LLM through two additions. It has access to external tools, and it operates on an internal logic loop. This agent core schematic details the architecture that makes autonomy possible. Driven by a system prompt, the reasoning and planning phases allow the agent to take a massive, ambiguous goal and break it down into actionable microsteps. During the action phase, the agent uses its assigned tools to interact with the outside world. It can browse the web, trigger APIs, or query internal databases without human intervention. Crucially, the feedback loop allows the agent to evaluate the result of its own action. If a step fails, it reasons through the error, adjusts the plan, and tries again until the goal is achieved. The potential return on investment is massive. This is true workflow automation that completely removes the human bottleneck from complex, repetitive tasks. But the trade-offs are severe. Autonomous agents are brittle in production and incredibly expensive in compute costs. If not heavily monitored, they carry the risk of getting stuck in infinite logic loops, burning through API credits while accomplishing nothing. Agents represent the absolute edge of current automation. Because of their inherent instability, you should only deploy them when standard human-in-the-loop systems are no longer viable for your scale. Knowing how the technology works is only half the battle. The actual decision comes down to matching your primary workflow to the correct tier. This functional decision map routes your business goal directly to the required architecture. If your primary goal is data strategy, like forecasting Q4 sales or clustering user behavior, you must mandate traditional machine learning. You sacrifice the trendy generative features, but you secure mathematically proven results for a fraction of the compute cost. If your goal is knowledge management or automating customer support using proprietary data, a RAG pipeline is your non-negotiable baseline. You will have to pay the heavy tax of building and maintaining vector databases, but that investment guarantees factual accuracy and protects your brand reputation. If your goal is true task automation for complex, multi-step workflows, you follow the path to AI agents, knowing upfront that you must invest heavily in monitoring and strict operational guardrails. The operating principle is simple. Architectural complexity is a cost, not a feature. Never build an autonomous agent when RAG will suffice. Never build a RAG pipeline if a basic machine learning model solves the problem. Evaluate your goal and choose the lowest tier that gets the job done.